Hello everybody. On this video I'm going to be doing numbers 5, 6, and 7, and then I'm skipping ahead to the end of the packet to do a couple more problems. So let's take a look at numbers 5 and 6 at the same time. Both of these, I'm noticing that I do not have a lead coefficient of 1, which means I'm most likely going to factor by grouping, or split the middle, or I'm going to do quadratic formula. And so how about for both of them we get both of these equal to 0. So 15x squared minus 14x minus 8 equals 0. In this example, 3x squared plus 4x minus 3 equals 0. What I'm going to do first is check to see if either of these are factorable. So let's see if we could use split the middle term on either of these. This one, if I use a times c, I would get 15 times negative 8, which is negative 120. And so if I think about all the possible numbers that could multiply to be 120, 1 and 120, 2 and 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 7 no, 8 no, 9, 10, 10 times 12. Do any of these pairs also combine or add to be negative 14? Yes, this pair does right here if I have negative 20 and positive 6. So this one I can factor by grouping, eventually, or split the middle term. If I look at number 6 and I try the same thing, if I do a times c, I would get negative 9. The only pairs I have for 9 are 1 times 9 or 3 times 3. Can either of these pairs combine to be 4? No, they can't, which means this problem I'm going to use the quadratic formula for, and this problem I'm going to do with factoring by grouping, aka split the middle term. And so if I do this first, I'm going to take negative 14x and I'm going to split it into this fact. So I'll put the 6 first and the negative 20 second. You can switch the order if you'd like. So I'm going to split this to be 6x minus 20x. I'm going to carry down the 15x squared, and I'm going to keep this 6 as a positive because it's 6 minus 20 equals negative 14, minus 8 equals 0. Now if I group the first two and the last two, the GCF here would be a 3x. If I take 3x out of both, I'm left with 5x plus 2. And here, if I have a negative in the middle, I want to carry that down. And the biggest number I can take out of 20 and 8 would be 4. And if I do that, negative 20 divided by negative 4 is a positive 5. Negative 8 divided by a negative 4 is a positive 2. These two parentheses match, which is a good thing, which means this factored to be 5x plus 2, 3x minus 4 equals 0. So at this point, if I set both of these parentheses equal to 0, 3x minus 4 equals 0, my answer here would be a negative 2/5. My answer here would be a positive 4/3. Now, if you wanted to, you could have used the quadratic formula again. The reason I chose not to in the video is to remind you that both of these are options. Number 6, unfortunately, we could not factor this. So I'm going to erase this at this point, and I'm going to use the quadratic formula. And it's going to turn out that my answers are imaginary, which is why I could not factor it. Now, before we begin the quadratic formula, I just noticed something. Some of you might have noticed earlier. When I moved this 3 over, I should have added it. So there should be a plus 3 here, not a minus 3. So now if I use the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So if I follow the order of operations here, underneath the radical, I'd have to square first, so I get 16. All three of these numbers are multiplying, so 4 times 3 times 3 is a 36, but the symbol that goes in between, because I only see a subtraction sign or one negative, negative times positive is still a negative. And all of that is going to be over 6. So that would be x equals negative 4 plus or minus the square root of negative 20 all over 6. Now, as soon as I see a negative under a radical, I know that the answer is going to be imaginary. If I kept simplifying that, though, because your goal is to simplify this down as much as possible, 20 is not a perfect square, but I can simplify that by taking out a perfect square of 4. So we have negative 4 plus or minus. If I needed to split this into two radicals, my suggestion will be putting the negative with the perfect square. So negative 4 times root 5, negative root 4 times root 5 over 6. X equals negative 4 plus or minus the square root of negative 4 is 2I root 5 all over 6. Now, at this point, what we did earlier was we made or looked at that all three of these numbers are our greatest common factor, and so we took out a GCF of 2, so we're really dividing everything by 2. So we have x equals negative 2 plus or minus 1I root 5 all over 3. Now, if we want this answer to actually be in complex form with a plus bi, we should write these separately. So the final answer would look like this. Negative 2/3 plus or minus, we don't really need to write 1i, so I'm just going to write, you could either write I root 5 over 3, or you could write root 5 over 3i. So you're saying this is the real part of the number, and this is the imaginary part of the number. So if we're sticking with, and again, this really has to do with section 7.8, which was the most recent one. This has to do with the formatting of a plus bi. Technically, your answer should look like this. Now, last problem I'm going to do in this video is number 7, and it asks this. Describe how many possible solutions, or x-intercepts, or roots, a quadratic equation can have. As soon as you see the phrase quadratic, that means it's automatically a parabola. So I know that eventually, because it's asking me to draw down below, I need to draw a parabola. So if you think about it, if you're drawing any kind of parabola, there's really three situations because x-intercepts have to cross the x-axis a certain amount of times. The parabola could cross twice, it could cross the x-axis once, or it could cross the x-axis never, or 0 times. And so to draw each situation, remember that roots and x-intercepts are one and the same. So this picture could look something like this. It might even be different than my key. As long as your picture hits twice, that's great. You could have even had a parabola that's upside down and hits twice. I mean, it's up to you. Case 2, one solution. That means that the parabola is going to hit the x-axis one time. So it's going to hit one time on the x-axis. It could be facing upwards. It could be facing upside down. Either way, either of those sketches is fine. In case 3, it's never going to touch the x-axis at all. So either your parabola is facing upwards starting above the x-axis, or it could be below the x-axis going down forever. So all of those are possibilities for part A. Part B is asking you to describe how the discriminant relates to each case. So the discriminant, you remember, is really just the part underneath the radical in the quadratic formula, the b squared minus 4ac. So I'm going to write that in each blank, but the discriminant has to be, in order to hit the x-axis twice, the number under there has to be bigger than 0. Or another way, the discriminant must be positive. If b squared minus 4ac equals 0 exactly, then you're going to have one solution. If it's positive, you have two solutions. And if b squared minus 4ac is less than 0, meaning if the discriminant, so this one says discriminant as well, DIS, I just abbreviated that. If the discriminant, if it's must be negative in order to have 0 solutions. So to give you an example, if you're doing the quadratic formula and you ended with like 5 plus or minus the square root of 47 over 2, you know there's going to be two answers because 47 is a real number. You'd have 5 plus this and 5 minus this, all over 2. In this example, if you had like 5 plus or minus the square root of 0 over 2, the square root of 0 is really just 0. So you'd end up with 5 plus or minus 0 over 2, which is really just one answer if you think about it, because 5 plus 0 and 5 minus 0 is really the same thing. The last example, if you were doing the quadratic formula, would be something like this, like we did earlier. If you have something like the square root of 20 or square root of negative 20, that's when it never touches the x-axis. It has 0 solutions. And so on the test, if we ask this, we're looking for this type of definition, that b squared minus 4ac is a positive number or bigger than 0. b squared minus 4ac for one solution hits the x-axis once, so it equals 0 exactly, or b squared minus 4ac is less than 0 or must be a negative number in order to cause 0 solutions. All right, guys, so the next time you'll hear from me is the last couple problems. I'll be doing 16 and 17 on a third video. Thank you.